Hi, can everyone hear me? Not too loud? Okay. So my name is Catherine Renwick. I work in Workday. For anyone who doesn't know, Workday is a cloud provider of enterprise applications in financials and HR or human resources. Okay, so you may have heard of Workday or you may not have heard of Workday. Today I'm going to talk about technologies that scale for growth. And actually, in thinking about the title, I probably put it the wrong way around. What I'm actually going to talk about is how we've built technologies for scaling. And when I mean it's how we've scaled certain technology areas in our stack. And I also want to call out some of the technologies that we've used to enable that growth. Sorry, I've got to figure out how the clicker works here. Wrong way. Sorry, one sec, guys. How do we go? It's like this. Oh, I had the clicker upside down. Okay, let's try this again. Okay, excellent. So it's good when you hold the clicker the right way around. So background. So before I get started, I wanted to give everyone a little bit of background on what we do in Workday, because I think it's important to frame the conversation. So first thing about Workday is we're a SaaS application. We deploy weekly to production. So we send updates out to our customers on a weekly basis. That's sort of true and sort of not true. Some of our services deploy continuously. Some of our services deploy more than weekly, but at least once a week, every single one of our services gets updated on a Friday night. Secondly, we're single code line. So that means we develop on the code line that we deploy to production. We use extensively feature toggles and test pipelines to enable us to be able to do that. Thirdly, we run private clouds. So we started in a private cloud environment, and now we run in public clouds as well. But we started 13 years ago when private cloud is how you started. So we do run mostly in private clouds. The next two slides I'm going to give you a bit of background on is our overall architecture. So Workday, this is how we think about our architecture, okay? So if anyone's interested in our overall architecture, you can look up Workday and architecture in a search engine, and first hit should bring you to this, okay? There's a blog post, there's a video that runs through our architecture, okay? But if you see this, we think about our architecture like it's a town, and you drive around the town, okay? And so in this slide, I've called out a couple of landmarks that exist in our architecture. So there's two ways to come into the system. You either come in through the user interface, okay, so that's through the Workday way there, or you come in through Automation Drive, and that brings you into the API gateway. So that's if you're doing web services or you're doing REST stuff, you're going to come in through Automation Drive. Sitting behind them is the transaction services. So we're a transactional system. We're a HR and financial system. So we have our transaction service as one of our landmarks. At the back here, we have our big data system, okay? So that's where we allow you to do analytics on large sets of data. We also have business data that we save over here, and we have a console. And that console is kind of where I'm going to concentrate a lot of my effort on this talk today. But these are just particular services that exist in our architecture, okay? In this slide, I give you the core areas of our architecture. So over here in the green, you have our user interface services. There's a whole big bunch of services that exist in there in order to be able to serve our user interface. Down here, you have integration services. So as well as our customers going in through the UI, they also come in through web services and REST-based endpoints, and they use integrations to do that, to get data into the system and to get data out of the system. In the center of the system, you have the object management services. So when I said earlier on about the transaction service, that sits in there. But also what sits in there is our reporting services, our caching services, and anything that kind of transacts data. Sorry. At the top there, you have our analytics. And analytics is where our customers can perform analytics on their data in the system. So let's say you're a customer and you want to be able to do some group by, filtering, trending on data that exists in the Workday system, or your data that exists in the Workday system. You use our analytics system up there. You can do data discovery, you can do joins, you can do groups, you can all that kind of stuff in order to be able to interact with the data and create dashboards and visualizations. In the center there you have deployment. So deployment is, when you're a Workday customer, okay, you need to be able to deploy Workday. And deployment is how our customers deploy Workday. So when you become a new customer, you want to be able to ETL your data into Workday. You want to be able to create your integrations. You want to be able to create your business processes. You want to be able to put in your historical data. We have a set of deployment tools that exist there in the center that allow you to do all those things. At the back here, we've got our persistent services. So there are big data services, our database services, and I pointed out one of the landmarks there earlier on. I am going to talk today about the operations services. So if you're not interested in DevOps, this may not be the place for you, but this is where I'm going to spend the majority of the talk today. So, why is probably the wrong word here. What am I going to talk about? I'm going to talk about scale, okay? And when I think about scale, I don't just think about how we scale to number of transactions. Because when I say scale to you, you think, oh, billions of transactions. But actually, scale is a little bit more than that, okay? Scale is actually how you scale your company and your organization in order to be able to grow as well. So when I talk about scale, I'm talking about both scaling our transactions and how we scaled our organization and how we've scaled our technology set to be able to grow with the number of customers we have and also with the number of teams that we have and services that we deploy as part of our system. So one of the other things I want to call out is what I'm going to talk about here are 3 journeys, okay? And when I say journeys, they're like 3 stories. And it's the story of how we grew 3 areas in our technology stack. The first area is going to be configuration. The second area is service deployment. And the third area is monitoring and alerting. So I'm going to read out the story of the last 13 years of how we've grown these areas, okay? But one thing has been very clear that as we've been growing these areas, we've been building towards continuous delivery. We've been building towards scale. We've been building towards being able to make these services self-service. So I'm going to start with configuration. Let me dig in a little bit to what configuration is, okay? There's many ways you can configure a system. There's configuration of the service, there's configuration of the infrastructure, and there's configuration of maybe the application that sits on top, okay? I'm going to talk about configuration of the infrastructure, okay? Again, back to our architecture diagram, you can see that our configuration sits there alongside service discovery, key management, tenant supervisor, and service deployment, okay? So I focused in on one area of operations, and these are the services that we build that sit in those areas. So the way I've visualized this journey or this story is through these steps, okay? And each step we've introduced a new thing to the technology stack, okay? I also call out some of the technologies that we use in order to facilitate that step. These steps, like that first step started, I don't know, many, many, many years ago, okay? And then our 6th step is pretty much where we are today. Each of the journeys that I show you will bring you up to the 6th step of where we are today. So this is kind of going back in history so you can appreciate how we got to where we are today. So the first step, okay? So the first thing we decided we needed to do many years ago was to automate at the host level, okay? When we started looking at this, there was only 2 tools. There was Chef and there was Puppet. There was nothing else. So you had this or that. We chose Chef. The reason we decided to do this is because we were doing this manually beforehand, and all of our systems were not the same. We did not have consistency across our systems, and then we couldn't be sure that the systems in one environment would act the same as a system in another environment. So we decided to automate each of the systems using Chef. So we built lots and lots of cookbooks for configuring every system. Now that was great, okay, and it meant that we had consistency across all of our infrastructure, but when we went to deploy this on a Friday night, the whole process for actually deploying The automation was manual. We copied all these files around. We turned on the chef clients. We watched them all converge. So the next thing that we did was we created a deploy tool that allowed us to do that in an automated way. So then on a Friday night, somebody pressed a button and all the configuration went everywhere and everyone was happy and they could sleep. The next step was to build pipelines, okay? So traditionally, and it's not the case today, when you built infrastructure code, you didn't build pipelines. Now, we kind of looked at that the other way around and we said, if you're building code, you're building pipelines, okay? So we implemented Jenkins, we created unit tests, system tests, integration tests. We used AWS to create these test pipelines. So all of the code that we built for configuration was the same code that was tested before it went into production. And everyone's happy again. But the next thing we needed to do was that we had one team working on all of this and we needed to scale. So this was our big scaling point, okay? We needed to enable other teams to own their own cookbooks because if all of the cookbooks were going through one team, we were not going to be able to grow. So we created a self-service pipeline. With the self-service pipeline, we used Kubernetes or Jenkins on Kubernetes with Docker containers. In this way, teams could create their own pipelines using Jenkins on Kubernetes clusters. They could roll up their unit test environments, they could roll up their system test environments, and they could deploy into test to test their changes. So everyone ended up with their own little pipeline this way, okay? So they weren't all together. So although this is brilliant, okay, what it didn't give us was independence. Still on a Friday night, everyone was deploying together. So during the week, you could all test it independently, but on a Friday night, we wanted people to be able to deploy independently as well. So then we implemented independence using Chef organizations. And I'm going to show this on the next slide. And finally, we're in the world of simplify. So over many years of building this system, we've probably created a little bit of debt, okay? And no, although I put simplify as a step here, it exists everywhere, okay? So it has existed at every step where we're constantly going through and refining and rebuilding and, re-implementing tests and pipelines and cookbooks. So on this next slide, I'm going to show you what our pipeline looked like before we implemented independence. A team would develop a cookbook. At any time, they would build that cookbook, they would test, and they would deploy to dev. At one point in the week, we would select a version, and we would deploy that into our DR environment, our non-prod environment, and our prod environment. Oh, great. But actually, we wanted to break that apart so teams could deploy independently. So, sort of the same process, but a little bit different. Teams still develop cookbooks. They're still able to build at any time. They're able to test at any time. And now they're able to deploy into dev alpha at any time. Then we have a release manager who's able to deploy whenever they choose, because it's a decision at this stage, into dev beta, DR, non-prod, and prod. So you can see where the evolution is. Our service teams, although this infrastructure exists, our service teams actually exist somewhere in between the self-service pipeline and this pipeline. So they're moving, but all the tooling is available for them to be able to do this. The next story I want to tell is about service deploy. So this is the deployment of the application itself. And the same as the previous one, you can see that it exists there in the configuration space with tenant supervisor and service discovery. So here's my ladder for service deploy. At the very beginning, we had Bash. We had RPM. We asked teams to build RPMs. We had Bash, and we deployed RPMs using Bash. And we kind of said, okay, we need to make this a little bit better, and we need to scale this, okay? It's very difficult to create error handling in Bash. It's very difficult to know when there are errors. It's very difficult to create unit tests. And so it doesn't allow you to actually test what's in dev, what you deploy into production. So we created a deploy service. We had to build this ourselves because there's actually not a lot of deploy services that exist in the world, okay? This is an area that people generally have to build themselves. So we started building a deploy service, and that was working quite well for us. But one of the things that became very clear to us is the configuration of the service is as important as the code for the service itself. And somehow you need to put those two things together, okay? And you need them to travel as a package. Now remember, this is before Docker. So what we decided to do is to do image-based deploys, okay? So we would create an image. That image would contain all of the configuration, it would contain the service, and it would contain everything you need in order to deploy the service. We created an image-based service that we could put these things into a common store. That store would get replicated everywhere. And then we would deploy those images using OpenStack onto OpenStack clusters, okay? In that way, what we knew, what was going through dev was actually what was getting into prod as well. So the next stage in our evolution was around containers. So the one thing that image gives us is the ability to package the configuration and the container up and the code up together, which is really great, okay? But what it doesn't allow you to do very well is actually to test locally. So it's very difficult to test images on your local system or to dev against images on your local system. So we then asked for teams to build Docker containers that we could put into the images that we deployed into production. So this, again, worked very well, but we needed to move to the next stage, which was orchestration, because you need the ability to be able to orchestrate bringing services up and down as you're going through zero downtime or as you're going through deployment. So this is actually where we pivoted a little bit, okay? At this point, we were looking at public cloud, and we decided to rethink what we did here. So we implemented Kubernetes with Docker containers with Helm config on public cloud in order to be able to orchestrate the deployment of our containers. Now remember, we're still in private cloud, and we're also in public cloud. So the same container works in both places, but the underlying infrastructure is a little bit different in both places. And this eventually allows us to get to a place called ZDT. So let me draw what that picture looks like for you, okay? So basically a team is able to build their code, build a container, add in their Helm config, run tests, and then release into our environments on Kubernetes clusters. That's overly simplified, okay? It doesn't look like that. We've actually built a number of services that allow us to do blue-green deploys on the clusters and allow us to do rolling upgrades on the clusters depending on the service type. Some services are stateful, so you need blue-green. Some services are stateless, so you can get away with rolling upgrades. And so this picture is the picture that we want to exist in both our public cloud and in our private clouds, okay? So it's there in our public clouds, but we will start bringing this back into our private clouds so that they behave in the same way. So monitoring, this is my favorite space. So back to our architecture diagram. The monitoring system exists there. It's metrics, alerting, logs, statistics on the console, which is one view of everything. Again, the same stepping stone evolution. At the very beginning, you have Nagios, because that's all there was. The whole point of implementing Nagios was so that we knew when something went wrong before our customers knew something went wrong, okay? We created thresholds, we had alerts, we created a pipeline using Nagios. So with Nagios, every host has to have an agent on it, and they're a little bit heavyweight. So we also implemented service discovery so that we would know what we wanted to monitor. So we implemented our own hookup between Zookeeper and Nagios to be able to know what we needed to monitor, which was all that was available at the time. So that was great. What it gave us was alerts. We knew when something was wrong with the system, and we would be able to react to what was wrong with the system. It didn't give us any longer term data, okay? It didn't give us any trending data. It didn't give us any historical data. It didn't give us any data so we had to understand how the system worked historically and how the system might work in the future. So we implemented Stats Warehouse, okay? And basically what stats are their aggregated data about how the service works, okay? So if you think about how the service is working, you want to know how many connections am I opening? How many files am I opening? How much GCs have I done? How long are my GCs lasting? Have I gone into full GC? So you want to know all this information, but maybe also you want to be able to trend it over time. Oh, on a Wednesday does something happen so that I can see that, I have a trend or I'm able to figure out what's going on. So we implemented stats, and we built a stats client. That stats client went into every service, and then the stats got ingested into Hadoop, and we were able to do long-term trending over a Hadoop cluster. Next thing was metrics. So metrics is that kind of telemetry view of point-in-time measures, okay? So if you're measuring something point in time, how many connections, you want to be able to see that visualized over a period of time, and that's metrics. It's visualizing the behavior of the system. So we use a tool called Wavefront to implement metrics. One of the reasons we use Wavefront, it was extremely simple to set up. Took no effort. And that was what we were going for at the time. No effort in order to be able to get metrics. And you can create dashboards in there. So once you've got your metrics going in there, you can create dashboards. So you've got a visual representation of how your service is working. And this worked very well. But when you wanted to debug issues, none of these tools are able to give you the detailed data of what might be happening on the system actively. So the next thing you need are logs. Okay, and you need logs so you can debug what's happening in the system as something is happening. So our logging is real time. So maybe we detect that there's an issue, our alerting has gone off, people will go into the log system to figure out what might be going on. For this one, we use Kafka and Elasticsearch. So we use a Kafka client, we put that Kafka client into every service. Those Kafka clients then send logs onto Kafka clusters. We have a consumer at the far end that reads off the Kafka clusters, injects them into Elasticsearch where the data gets indexed, and we're able to search across log files across the service. So again, we hit that same scaling point with this technology in that we needed to create self-service, okay? And self-service for us was the ability for our teams to be able to create their own metrics. At this point, we'd been creating a lot of their metrics, or the monitoring team had been creating a lot of the metrics, but the monitoring team doesn't know how all the services work. We need the service teams to be able to create their own metrics. So we implemented Prometheus, Sensu, and Big Panda. I'm going to show you what that looks like on the next slide, so I'm not going to go into it in too much detail. So the final thing and the place that we are today is quality of service, okay? So in everyone's monitoring journey, you need to hit this place where you think about quality of service. The measure of success of these tools is that our quality of service is getting better. So now we're driving on mean time to resolution, mean time to discovery. We're driving on availability, and we're constantly reiterating on making sure that those metrics are visible for everybody, that they understand how their services are working in production, and that they're driving their availability up. So here's what the pipeline looks like for 13. Here's what the pipeline looks like for our self-service monitoring tools. Okay, so over here you have all of our services. So I talked earlier on about we've got the integration service, UI service, the transaction services. They all exist over there. Okay, we have used a Prometheus client that gets embedded into all these servers or all these services that basically publishes metrics checks to this collector here that pulls in those metrics. We discover the services via service discovery, okay? So we know which services to measure via service discovery. The metrics get pushed to this endpoint where they get collected. They then end up on a RabbitMQ cluster. They go from a RabbitMQ cluster to a Sensu cluster, and then onto a proxy, and then into Wavefront for visualization and telemetry data, and then into alerts and Big Panda for our NOC to look at and to react to, okay? So what's interesting about this? To my mind, the thing that's interesting is really around service discovery and the ability to be able, one of the things that you'll notice here is that Nagios has disappeared because Nagios has disappeared. We needed to move away from Nagios because it's quite static in nature and move towards something like Sensu because it's more elastic in nature. We need the elasticity of, we're in a virtual world now where we need to be able to, through service discovery, detect that something has just appeared in the network and start monitoring it. And Sensu allows us that elasticity that we didn't have before with Nagios. So, as I said at the beginning, I was going to spend a little bit of time on lessons at the end, because as we were building all of these technologies, there were obviously lessons that we learned, okay? Lots and lots of lessons. And I'm actually going to spend a little bit of time here because I personally think that these are important lessons because, through a number of failed endeavors, they've become very important. So, first one, have a vision. Okay, and have measures for success, okay? So when you start an initiative, okay, know where you're going to go or where you want to go, okay? Sometimes I see teams and they start their vision with a technology name. Oh, I want to implement Kubernetes. That's not a vision. That's saying you want to use Kubernetes. The vision is we need orchestration of our services so that we can implement CDT. That's a vision. Okay, so start everything with a vision, okay? And also define a measure for success, okay? And the measure for success is how you're going to determine that that thing has been successful. So let's go back to my example a minute ago with Kubernetes, okay? The measure for success there is that you're able to do ZDT deploys of a blue-green nature or a rolling restart nature in production. That's your measure of success. But start everything with a measure of success and a vision. 2, although you have the vision, don't implement the vision. So don't go and on the very first thing, try and implement everything, okay? Because you'll fail. So think big, but implement small. And this to my mind is the hardest thing to do in software engineering. You know the way there's 2 hard things in software engineering, like caching and naming stuff? Well, actually, I think this is even harder. Because honestly, people try and solve all the problems at once. Don't try solve all the problems at once. Try and solve measurable pieces of value, okay? Pick a piece of value, determine what it's going to bring to the business, okay? Because we're all in the business here of providing a business to our customers and a service. Measure that value and implement that value, okay? Like I can't emphasize enough how important this is. Next one, beware of inflated expectations, okay? I don't know whether this happens where you guys work, but sometimes it happens where I work. You go in and somebody goes, people have these, everyone's optimistic. That's what I've discovered. They're optimistic that they can solve all the problems in one fell swoop, okay? You can't solve all the problems in one fell swoop. So be super intentional about what you're doing and what your expectations are for what you're doing, okay? So when you start implementing a project, be intentional and methodical about, I'm trying to solve this problem, it adds this business value, and my expectations are this, and my measure for success are those, okay? It's like 4 steps. If you follow those 4 steps, your projects are more likely to be successful. So beware of inflated expectations. Sunk cost fallacy. Don't be afraid to pivot, okay? So when I say pivot, what I mean is don't be afraid to assess where you are and change what you're doing, okay? So the sunk cost fallacy is basically that you've spent so much effort at something that you got to get some value out of it, okay? So you've spent so much money on it, you spent so much investment in it that you have to get value out of this thing, so you keep going. Even if you determine it's not actually the right thing, you keep going. So what I'm saying is, actually, forget about the money you've spent already, the investment you've done already, it's gone. You can't get it back. It's disappeared. It's been spent. So don't be afraid to look at what you're doing and pivot and say to yourself, hey, is this actually the right thing considering where we are now? The technology space that we operate in is so growing. Like it's so new that like some of the technologies are less mature than other technologies. And as you're working on something, you may discover, hey, you know what? This is not the right technology for us. We need to think about a different technology for this, okay? So don't be afraid to pivot and don't be afraid to think about trying something new. And my last one is let flowers bloom, okay? Has anyone ever read the article called Let 1,000 Flowers Bloom and then pick out 999 of them? Well, if you haven't, you should, okay? It's one of my favorite engineering articles. It's about engineering efficiency, okay? So this guy basically said that he has an equation for investing in engineering efficiency, okay? And whatever, it doesn't really matter about the equation, but the very beginning of his paper is all about trying new things, okay? So he worked in Twitter. So in Twitter, they were very pragmatic about trying new things and about implementing the technologies that made sense at that moment in time. Okay, so part of the first part of that paper about letting flowers bloom is like, don't be afraid to allow things to grow. Don't be afraid to allow things to innovate. Don't be afraid to try new things. But then the second part of it is, don't be afraid to pull that flower out of the ground and throw it in the bin or trash can, because that's not what you need to do. Okay, so the whole point around let flowers bloom is to try stuff, but don't be afraid to stop, reassess, and think about whether that's the right thing you should do. So actually, that's my very last slide. I have 10 minutes left. 5 minutes. Oh, perfect. I literally was on time. So I have 5 minutes left for questions. I'm going to leave it on that slide if anyone wants to ask me any questions or not.
I'm just curious on one of your ladders. I think it's the last one on the management.
Yeah.
How long does it actually take you to go through that journey?
Oh, the journey? Years. If I was to give it a guess off the top of my head, I'm going to say maybe from the stats journey up was maybe 5 years.
Can you speak a little bit about how you have gone about pivoting, or not pivoting, but identifying the need for the change or the step up, and how you have implemented? I mean, you can speak about it.
So if I think about the need for the change, so if I go from logging to self-service here, okay, the minute that you see that it for us in particular, okay, what you start seeing is that you have one central team that has more work that they can ever complete, but also what's happening is that other teams with dependencies on that team can't be successful, okay, and that's where you need to start thinking about that's where we started thinking about self-service, okay? If you are blocking another team from being successful with what they need to do for the business, that's where you need to start thinking about doing things differently. Now, one way to do this is just to grow the team enormously. You could have hundreds of people on the monitoring team, okay? That's not the path we took. The path we took was to look at self-service, to provide self-service tooling with APIs and with clients and with pipelines to allow people to do these things themselves. Does that answer?
One of the challenges that we have is selecting tools. Maybe not during the night
or the chef time.
So in this world today,
there are so many.
what is your direction as a review?
So my direction is I actually like people to look, when we're looking to solve a problem, to look at different options, okay? Like the first option you're going to look at is actually you're going to build it yourself either. So some option is that you may build it yourself, okay? If you determine that there's something out there where you don't need to build it yourself, then you start looking at those tools that are available. One of the most important things for us is scale, okay? That thing can scale and that it's stable. And so we do spend a lot of time on those two things as criterias: stability and our ability to scale that thing, okay? And scaling could be through just, horizontally scaling it. Horizontally scaling it, yes, yeah. But that there are two criteria. But we do look at different options. We don't just go for the first cool new thing. The other thing is that sometimes some of our choices aren't as obvious as you'd think, okay? Like people go, oh, why did you use Wavefront instead of Grafana? Well, we looked at Grafana, we totally did. But actually Wavefront was much easier for us to set up at that time. And this is a time when we were in the middle of doing stats and logging, and we're building all of these things, and we needed something that was just very, very simple. So you got to be pragmatic about the problem you want to solve as well. I like that they're being called ladders. I call them steps. Sorry, lots of clicks. We just want a picture. I believe they all get published. The other thing, actually, now that you reminded me about my stepping stones, is that our teams are in different, and I mentioned this at the beginning, our teams are in different places on these steps, okay? Some teams are all up at the top, some teams are in the middle, but we do have an array of teams in different places on all of the steps, okay? The steps that I see here are the toolings that we've provided in order to enable these teams. Well, you start with a vision, okay? So at the very beginning, we had a vision for where we wanted to go, okay? And when we started this, I said, we are going to need self-service metrics and alerts, okay? That's where we need to be, okay? And so sometimes the steps flowed a little bit differently depending on what we were doing. And this is historical. I'm going back over what actually happened. But yeah, no, totally at the time, we could have decided, no, we need to do logging now instead of doing metrics, okay? But I think we tried to work with business value. The most important thing in the monitoring space is categorically alerts, okay? The first thing you have to get right are alerts. Okay, and then everything else you can build on top of that.
As you speak to that change, it might also happen to maybe some.
Oh, yeah. Oh, yeah, totally.
So have you had any examples where you have to maybe build on the vision itself to accommodate the circumstances or everything that's happening in terms of technological inclusion?
So I'd say in service deploy, we've pivoted a few times, okay? At the very beginning, we thought we'd build a nice service. Oh, time's up. I'm being told time's up. Okay. At the very beginning, we started thinking, hey, we'll build a UI and we'll have a button and it'll all be great, okay? But as we started building these things, we discovered that more and more things were important. And actually, we have a UI with a button, but actually that wasn't what became the core competency of the vision. What became the core competency was getting to a spot where we were able to do containers and able to do Kubernetes. That's it. Time's up, so I got to go. Thanks, everybody.